Good morning, guys. Now we will start solving some problems on chapter 7, which is to find the internal forces. Basically, as I said, the objective is to draw the the shear force diagram and the bending moment diagram, because usually the normal force is equal to zero. Because in fact, guys, the loading is almost vertical, so there is no normal force. Now, I will start by the very simplified example, which is example 1. So I have a symmetrical beam. I have 1 point load at the midpoint of this beam is equal to 5 kilonewton. And the question is to draw the shear and moment diagrams for the shaft. I know that at A I only have uh, uh, one reaction, and at C I only have one reaction, no horizontal reaction here because there is no horizontal force. So let's do it. So as we said, guys, in the procedure, the first step ever is to find the reactions. Alright, so I will find the reactions here. I have two vertical reactions, one at A and one at C. And I will take this whole beam as my free body diagram in order to find these reactions. In fact, I only have two unknowns, so I can find them directly by doing the sum of Fy, because in fact I don't have any Fx. So sum of Fy is equal to 0. This will give me that RA, R at A plus R at B is equal to 5 kilonewton, because 5 kilonewton is downward. And I know from the sum of moments around A, you can take it of course around C, is equal to 0, that basically RC times 4 minus 5 times 2 is equal to 0. And this means, guys, that RC is equal to R at C will be equal to 10 over 4, which is 2.5 kilonewton. And if I go back and replace here, sorry, this is RC, and replace this equation by RC is equal to 2.5 kilonewton, this will give me that RA is also equal to 2.5 kilonewton. I can predict this because of the symmetry. So as you can see, guys, I have a symmetry here, two vertical reactions with one force at the midpoint of this beam, which means I have symmetry, so RA should be equal to RC, and since their sum is equal to 5, then they should be equal to 5 over 2, which is equal to 2.5 kilonewton. So this is the first step. So here, guys, I found the reactions. Now the second step is to make the cut. And remember, I should make a cut before the force and after the force. So let's do it. So I will start by this cut here. So the first cut, basically, is when x is between 0 and 2. Now what is x basically, guys? X is from this point to the cut. So this is x. So here, guys, x is between 0 and 2, and this is my first cut. And then, guys, I should draw now one part of or one of the two parts of this cut. So I have one left part and one right part. The left part is from A till X, and the right part is from the point X till the point Z. So of course here it is much easier to deal with the left part because I don't have any other force than the reaction at A. So I can, guys, take the left part and do my calculation. So I will draw here my left part. So basically this is A and this is X. And guys, don't forget that at X I have a downward V. Okay, so guys, don't forget that at X I have a downward V because this is the left part, and I have a counterclockwise moment. So a downward V and a counterclockwise moment. This is, guys, how you should put V and M using the sign convention that we talked about in the previous video. Now what I should do, basically, I should apply the equilibrium equations. So basically, guys, I should say sum of Fy is equal to 0 for this left part. Now what do I have? I have the reaction at A minus V, because V is downward, is equal to 0. And this means, guys, that V is equal to Ra and it is equal to 2.5 kilonewton. So guys, here for any x between 0 and 2, the shear force is constant and it is equal to 2.5 kilonewton. What about the moment? As I said, guys, in the previous video, you should take the moment. You should take the moment at x. Alright? In order to get rid from v, you should take the moment at x. So sum of moment at the point x is equal to 0 will give me what? I have the force RA, so RA times x, because guys, I cannot say it is RA times 2. Now here the distance is x, and pay attention, guys, because all the students will fall in this mistake. It is RA times x and not RA times 2. Now RA times x is in the opposite direction to m. It is clockwise while m is counterclockwise. So basically, guys, RA times x minus m, or m minus Ra times x is equal to 0, which means, guys, that m at any x between 0 and 2 is equal to Ra, which is 2.5x. This is the equation of m for any x between 0 and 2. Now the second cut, guys, should be after the force, as we said in the previous video. So this is the second cut. So if I do the second cut, now here, guys, x will be what? Will be from A to this cut here. So this is x now. So x, guys, is basically greater than 2, which is the point, the location of B. So it is greater than 2, but it is less than the length of the beam, which is now 4. So this is my second cut, basically. So the second cut is when x is between 2 and 4. Now, let's draw this cut. I want you guys to know that here, in this case, of course, the right part is much easier to deal with. Why? Because if I do this cut here and I take the left part, I will have a reaction at A, a point load at B, and I need to find V and M at this point X here. While if I take this right part, I will only have one force, which is the reaction. Now here, guys, I will take both parts to prove to you that you will have the same answer. First of all, I will take the left part, all right? So if I take the left part, so basically this is my A and this is my X. I have RA here, and then I have a point load at B far from A by 2 meters. So this is a point load equal to 5. And this is my X here. And at this X, guys, V, because this is the left part, V is downward and M is counterclockwise. Alright, so what I want to do here is the same procedure. Sum of Fy is equal to 0 to find V, and sum of moment around X is equal to 0 to find M. So the same procedure that I did in the first cut. So basically, guys, sum of Fy here is equal to 0 will give me that A, or Ra minus 5 minus V is equal to 0, which means basically, since Ra is 2.5, 2.5 minus 5 is minus 2.5 is equal to V, which means, guys, that V is equal to minus 2.5 kilonewton. So this is V, guys. Even if it is negative, I know that this V should be upward. It is not downward, but I should start by V is downward because this is the convention. Alright? And then I will not change the direction of V. V here is negative. I cannot change it because, in fact, guys, I will draw the shear diagram where V is by convention downward for the left part, alright? And now if I do the sum of moment around X equal to 0, so I will have, guys, that RA times all X, so don't forget it is times X, minus 5 times what, guys? 5 times this distance right here. Now, what is this distance? So, what is this distance here, guys? So, let's show you this distance. What is this distance here? It is basically all the x, because this is x. I know that this is x, alright? So, it is all x minus this distance from A to 5, which is 2. So, it is x minus 2. So, let's continue the equation. X minus 2 minus m is equal to 0. So this is the equation of the moment. And this means, guys, that the moment basically is equal to what? It is equal to 2.5x minus 5x, which is minus 2.5x. So it is minus 2.5x plus that. This is the moment at x. Okay, so for any x between 2 and 4, the moment is equal to minus 2.5x plus 10. So guys, you can see how v is changing. So for the first cut, v is equal to 2.5. For the second cut, v is equal to minus 2.5. They are both constant but different values. Now for the first cut, m was equal to 2.5x. Now for the second cut, m becomes minus 2.5x plus 10. Now guys, let's take the right part of the second cut to prove that you will have the same answer. Now, the right part is much easier because I only have one reaction, alright? So this is the right part. Let's say this is RC, and I will take this as X prime. And don't forget, guys, that if I take the right part, then V should be upward. So this is V. And M should be what? Should be clockwise. So this is by convention. This is V and this is M. Now, guys, what's the relation between X prime and X here? So X is from A till the point of the second cut, and X prime is from this point till the end of this beam. So basically the relation, of course, is that X plus X prime is equal to the length of the beam, which is 4. And this means, guys, that X prime is equal to 4 minus X. So why I'm doing this relation, you will see now. So let's start, guys, by what? Let's start by the sum of Fy is equal to 0 like we did for the second cut. So the sum of Fy is equal to 0 will give me what? I only have two forces here and they are both upward. So Rc plus V is equal to 0, and this is basically means that V is equal to also minus 2.5 kilonewton, and this is the same answer that I got from the left part. Now if I do the sum of moment around X prime here is equal to 0, what does this means? This means that M at X, or at X prime, sorry, will be equal, because they have different direction. It is equal to RC times X prime, which is basically 2.5 X prime. Now here, guys, you can see that in this case I got that M is equal to minus 2.5 X plus 10. Now here I got M is equal to 2.5 X prime, but if I replace X prime by 4 minus X, I will get the same answer. So 10 minus 2.5 X, which is the same answer at the left part. So here also, don't forget that here, if I do the calculation, m of x will be also the same 10 minus 2.5x. So basically, guys, I will have the same answer if I take the left part or the right part. But don't forget, guys, that if you take the right part, you should replace x prime by its value or its equation in terms of x. Because here, guys, your x is different than this x prime.